Let's move to our next keynote profile. I'm honored to introduce Sudeep Annappa Shanubhog, independent researcher and technical lead in enterprise platform architecture based in North Carolina, USA. He specializes in enterprise architecture, scalable system design, cloud enabled platform, and digital transformation. His keynote topic is Architectural Patterns for Autonomous Cloud Systems Towards Self Optimizing Enterprise Platform. We look forward to his insights on the future of autonomous and scalable cloud system. With that, let's warmly welcome Mr. Sudeep.
Thank you. Thank you very much for let me share this screen. I hope all you can see my screen and also can hear us.
Yes, sir.
Thank you. So good morning, good afternoon, good evening, wherever you guys are from. So today I'll discuss the architectural foundation of autonomous cloud system capable of self-monitoring, self-optimizing, and self-healing within distributed enterprise environment. As a cloud-native systems which grows increasingly complex, static orchestration and reactive monitoring models are no longer sufficient. We are moving toward adaptive intelligence embedded architectures, particularly within Azure native and modern document ecosystem. So this talk frame the frame autonomy not just an automation, but as an architectural paradigm shift grounded in distributed system and in AI integrated engineering. The main focus here is the transition from reactive as infrastructure as code to proactive autonomous cloud. The key concept here I'm planning to explain this topic is we are not just building an automation by a script or by playbooks. We are going to create a self-optimizing platform that utilizes closed-loop feedback without human intervention. I'll move to the next topic, next slide. A brief overview of my background will help us to establish why I'm choosing this topic and how closely it aligns with my experience and expertise. I've been working 20 plus years of experience in Microsoft technologies, C# .NET Code, and I currently work at PwC, PricewaterhouseCoopers, as a technical lead. My work has focused on architecting high throughput real-time enterprise platform and integrating with AI-driven decision systems within cloud-native infrastructure. I hope I pasted my LinkedIn profile if you want to have more questions or you want to connect or if you want to follow me. So the next slide, the context. I want to give a context, like why do we need this system which can improve the performance of the cloud architecture and it can self-sustain to improve the tools, whatever you're using it in the Azure cloud platform. So we're talking about highly dynamic workload, and it is going to be real time, and this is going to be globally scaled. It is just not applicable for one of the pod which we are looking for. So we might work with multiple pods, and it can also improve across the platform, and it will also self-sustain so that it can understand what is going on with each pod, because we are working on a microservice architecture. So obviously each pod will individually designated to a separate task, which would help us to understand if the one task has been broken or it has been stopped responding. Other pods are not being affected by this architecture. That's the reason right now I'm just trying to explain architecture here. So traditionally, rule-based scaling and static testful monitorings are insufficient in handling unpredictable workload patterns. This motivates a shift towards systems that can continuously observe themselves and intervene in operational processes, optimize the resource allocation, and adapt automatically to correct the issues. In other words, systems that are architecturally autonomous. I'll move to the next slide. So we are just following one model here, which is closed loop autonomous. So what exactly happens here is that it starts monitoring the process, it analyzes it, and then it optimizes, and it executes to fix the issue. So how we can able to achieve that? We can achieve by collecting the telemetry-driven data. It's called telemetry metadata from distributed services. An analysis applies statistics and machine learning models will analyze the entire process and optimize it based on the data collected from the previous uh, metadata. And based on our tools, which we can be able to write it in Microsoft.NET Core, or we can create an agent which does this job through an LLM, execute to enforce that it adjusts that particular process to make sure that the whole application runs smooth. The key architectural insight is that feedback loops must be embedded as a first-class primitive. That means it is going to take the effort. It is going to drive the entire process. Autonomy emerges when this loop is continuous, low latency, and intelligence driven. Let's move to the next slide. So, operation of this model requires layered architecture. The infrastructure layer, the first layer is, and we are using the Azure Kubernetes service, which is for AKS. Within the AKS, we might have multiple set of configuration settings. And similarly, Azure will also holds the app services or the function apps or trigger functions and compute resources. The next layer is telemetry layer. Azure monitors all these data through application insights. And the next layer is AI inference layer, where it, based on the machine learning code models, it automatically understands what exactly is happening. And the next layer, orchestration layer, is the one which controls and it does the scaling, for example, or it applies the policies which are required to correct these issues. In this case, each layer maintains separation of concerns, integrates through real-time telemetry streams. This layered autonomy scales or stack enables systematic adaptation and rather than ad hoc automation. Next slide. So it's event-driven systems and AI observability. Based on my experience as a .NET Microsoft technology platform, using ASP.NET Core, we can create an event sourcing and CQRS, which is called command response segregation, integrates within the tool which we create so that it can able to understand. And it also decouples the every services to make sure that we follow the pattern of microservices. It writes, reads, the workload scale independently. And AI-driven through LLM, it observes, extends the traditional logging. It detects all the models based on the early deviation per patterns based on the history. And reliability on these models are really good. So we can able to improve this day by day based on the history. And ultimately, we can also set the intelligent alert to make sure that it is being alerted to the stakeholders, and also it can able to fix the issue or whatever that needs to be scaled up. It has to be scaled down. So all this stuff can be monitored through this agent or through this tool. So it becomes proactive rather than reactive. That's the ultimate part of this topic. So I'll go to the next slide. So predictive scaling and performance engineering. Rather than reacting to CPU thresholds, we can anticipate what could be the workload. Is there any surge between certain period of time, say December or November, and allocate resource primitively so that it will not increase the scale. So I'm talking about the pod scale. Similarly, it will not decrease the time when it is not at all required. So it is going to optimize the cost performance as a trade-off. So .NET runtime optimizations reduce the latency overhead, and SQL Server tuning supports hybrid transactional analytical processing. And architectural decision balance consistency, availability, and latency, revisiting the trade-off in autonomous context. Autonomy must preserve deterministic guarantees where required. The next slide. So this is open research challenge. We know that a lot of plus and minuses towards the LLM. So it's all about the training, the model, like how do we provide the data, feed the data, and improve the data so that it can able to accurately predict and take over the issues which commonly it requires human intervention. For example, formal verification of adaptive system behaviors. What happens in this case is that if if we determine that this kind of tasks which should not give to the AI or the autonomous job to handle, we can write the policy so that we can make sure that a human intervention is really required in order to make such kind of decision rather than doing automation. So we can set up all the policies. We can write the operational AI so that it can behave exactly same as what are in lower environments and also in the production environment. We can write some frameworks so that we can able to orchestrate this entire process so that it would not take control of everything, but rather the one which takes a lot of time from the DevOps engineers to manage these items. Autonomy introduces new research and at the intersection of shooter systems. AI and reliability engineering is the most common practices which where every industry, tech industries are following up. They're trying to build the pattern, trying to build the tools so that it can able to accommodate based on their specific requirements, based on their specific compliance. So that's the advantage of this tool, which could automate the entire process, streamline and run smoothly all our applications without any issues. I know this is a very small topic, but this is the challenge, this is the topic which came across my mind based on my expertise. So that's what I have presented to you. Conclusion, autonomous cloud system represent the next evolution of enterprise architecture. By adopting the closed loop feedback, the model, which I explained it in the previous slides, will help us to at least reduce the 50% of manual intervention by any other DevOps engineers, by any other. So these architectures are adaptive, resilient, performance aware, intelligent, integrated. These are the few terminology which I have used, but there are many. This is going to be helpful for anybody who wanted to utilize it for their enterprise organizations where they can able to manage the cost and also to make sure that sometimes it scales up, scales down so that it can perform at its best. Uh, Thank you for listening. Welcome for any discussions or questions.
Thank you so much, sir. If anyone has any question, they can raise their hand. So there are no question at this moment. So thank you so much.